main advantage is the fact that we are using 60 GHz coherent radar. The other solutions are usually based on the typical traditional proximity sensor. Yes, hello, my name is Paweł Kaczyński. I'm Central Applications Manager driving a COE group based in Future Electronics in Gdańsk, specialized in embedded applications.
Cool, so I'm Eamon from ipXchange and we're obviously at the Future booth. And Pavel's going to talk to us a bit about the Carpark Occupancy demo from Future Electronics. So would you like to tell us
Yes,
a bit more?
so concept of the demo is pretty simple. We would like to monitor whether the car park in the defined location is occupied or not.
Okay.
How we made it? So actually we are using Acconeer 60 GHz radar as a proximity sensor, so we can detect whether the car is targeting sensor or not. We are using STM32WBL evaluation kit with microcontroller with integrated LoRaWAN transceiver who can transfer the information collected by the sensor over the LoRaWAN to the application server. So in final stage we have a location of the car park and whether the car park is occupied or not, and what is the approximate distance between the sensor and the car.
Okay, so this will be one for each parking space?
Yes, exactly. Yeah. Or for example, if we can imagine that we have an EV charging station, which is occupied, but there's no charging itself, so we can see that probably wrong cars start to occupy that place. So it is very important information for the EV charging system as well. How does it work? So in general, we have a 60 GHz coherent radar, which can measure the distance from, let's say, 17 millimeters, even up to 7 meters is in this case.
Okay.
Newer revision of that chip can extend that distance even to the 17 meters. So the range is extremely high with very, very high accuracy.
Okay.
So the accuracy, you can even help you to detect whether someone is breathing or not. So it could also be detected like in hospitals to monitor the patients.
Okay.
So for any other targets. So this is a very good and accurate proximity sensor, to be honest.
And goes far beyond car parks then. Nice.
And we are connected to the microcontroller board, which is collecting the information and then send over the LoRaWAN to the application server.
Cool. When compared to kind of other similar devices, what would you say are the main advantages of this one?
The main advantage is the fact that we are using 60 GHz coherent radar. The other solutions are usually based on the typical traditional proximity sensor or typical conventional like photodiode and phototransistor, which measure the, let's say, amount of light coming back to the sensor, which is not good in terms of accurate estimation about the distance.
Yeah.
And the big advantage of the sensor is it could be just closed in the enclosure. Typical proximity sensor like optical or time of flight need to be exposed on the target. These can be just put into the enclosure and then do the job again.
Cool, so just much more accurate then,
yes,
and
accurate and
reliable.
And also prepared for a robust application. So we can even expose it on the water or something like that.
Oh, good.
Yeah.
Cool. So, anything you'd like to add about the show? It's quite nice to be back at Embedded World, isn't it?
Yeah, we are surprised about all the attendees. So we really would like to show all the demos we have on my booth, but also we have several booths on Future stand where we show large number of demos for every technology segment. So I would like to welcome everybody to our stand, and also to you. I will wish you a great show.
Cool, thank you very much.
Thank you very much.
Yeah, come to the stand, you can't miss it. Hi, it's Eamon back at the office after Embedded World. Thank you to Future for a great interview. If you'd like to find out more information or apply to evaluate the Carpark Occupancy demo, i.e. 60 GHz radar with LoRa connectivity, then head to the ipXchange website and subscribe for more content, follow our LinkedIn page. Thank you for watching.